All right, grade 11s, get out your notes. This, for the fall of 2020, will be the last section in Chapter 7, and it's a quick one. So, excuse me, you know the standard form of an equation by now. Go ahead and fill that in. Of course, we know that y can also be written as f of x, right? That means the same thing. And we know that the letters a, b, and c, we use small letters. Those are the coefficients of x squared, x, and constant c. You also know that a represents the concavity of the parabola and c represents the y-intercept. Okay, the quadratic formula. Now, there are some times when we can't factor, or we can't factor easily to find the values of x. We have gotten very good at it, and lots of things we can factor, and we can find that value of x that makes the function equal to 0, and we can find those x-intercepts. We have also used a graph to find those x-intercepts, but there are some times when we're given a difficult quadratic function that it is just too hard to find the factors. Also, sometimes the quadratic equation or the parabola does not cross the x-axis, and then we don't exactly know what to do either. So we have the quadratic formula, and this is a formula. We plug in the a, b, and c values from the quadratic function, and we get a value for x where y equals 0. The x-intercepts, also known as the roots or the zeros of the function, the place where it crosses the x-axis. Okay, here's the quadratic formula. Please copy it into your notes. X is going to equal negative b plus or minus the square root. Now, when we say plus or minus, that's where it's going to give us the two possible answers, because we're going to do one where we add the remaining of the formula, and the second part we will subtract the remaining of the formula. B squared minus 4 times a times c. And this entire thing, make sure this line goes under the b, the subtract b in the front, all the way to the end of the square root sign, is all over 2 multiplied by a. So in your mid-chapter test and in the review, even in 7.1 and 7.2, we practice determining the a, the b, and the c values. And that's where this comes into play. You need to find the a, b, and c values of the quadratic function and simply plug them in for their representing variables in the quadratic formula. So let's try one together. One more thing before the example. On the bottom, you can fill this in if you want. So far we've learned to graph the function with either by hand or using Desmos, and then to look for the zeros. We've also learned about factoring the quadratic function and finding the value of x that makes that factor equal 0. And now we're learning about the quadratic formula. Okay. So here we have a quadratic function. We can tell because it's of degree 2, right? There's a power of x to the 2. And we are supposed to use the quadratic formula to solve or to find our values of x that make the function equal to 0. So let's put it into standard form first. There's a positive 7 that needs to be moved to the left-hand side. So in order to get 0 on the right, we have to subtract 7x's. That will cancel or make 0. We also subtract from the left-hand side. And now we've got 6x squared minus 7x minus 3 equals 0. This does look like something we could factor and find the x-intercepts. We're going to practice using the quadratic formula. Either way you do it, you will get the exact same answers. So let's identify the a, b, and c here, which you can do. You can pause it and do that. And then we're going to plug it into the quadratic formula. Okay, make sure you have the signs right on the a, b, and c. So you also have to take the negative in front of the 7 and the negative in front of the 3. And then we plug them into the quadratic formula. So x is going to be equal to negative, that's negative as part of the formula, and then b is negative 7, plus or minus the square root of negative 7 squared minus 4 times 6 times c is negative 3. all over, this line needs to be under the entire thing, 2 times a. Okay, now we go through and solve. So negative 7 will yield a positive 7 plus or minus square root. I'm going to show all the steps here. So negative 7 times negative 7, or negative 7 squared, will be 49. And then negative 4 times 6 is 24, times negative 3 will be positive 72, I believe. Might have to pause it and check. And all over 2 times 6. Okay, that looks good. Sorry. Next step, 7 plus or minus 49 plus 7 is the square root of 121 divided by 12. 7 plus or minus square root of 121 is 11. We're asking ourselves what times itself gives us 121. The answer is 11 divided by 12. Okay, now here we're going to branch into 2 possible answers. We're going to have a 7 plus 11 divided by 12. The other possible answer will be 7 subtract 11 divided by 12. And so 7 plus 11 is 18 twelfths. That can be reduced to 3 over 2. The other option, 7 subtract 11, will be minus 4 twelfths, which reduces to negative 1/3. And there we have our 2 values of x. Now, if we were picturing this graph of the quadratic, we would have 1, 0 at 3 over 2, which is 1.5 if you want to go to fractions. I like, if you want to go to decimals, I like fractions. And then negative 1/3 would be about here. Again, this is a sketch. And was this concave up or down? It's concave up. So we're looking at something like that. Okay, and of course we write our solutions for x in a solution set. Okay, now here I prefer fractions, and I would expect that you would use fractions because 1 divided by 3 is a repeating decimal. We don't want to round off our answer, we want an exact answer, and therefore we would leave these as fractions. Okay, now this worked pretty nicely with the square root of 121. That worked out a nice even answer. We do have to know how to deal with square roots, though, when we're using the quadratic formula, because it doesn't always work out as nice as this. So let's do just a little bit of practice here. Drag that down, sorry. All right, let's do these 6 quickly. So the square root of 36, what times itself is 36? Well, you know the answer is 6. The way we write this is 6 times 6. And then because it's multiplied by itself, the answer is 6. Okay, square root of 72. 72 is not a perfect square. There's no number multiplied by itself that gives us the square root, or that gives us 72. So we can write that 36 times 2 is actually 72. Now the square root of 36 we know is 6. And then we're left with our square root of 2. Okay? And when we're talking about an exact answer, that would be your answer if you came to the end of the quadratic formula and you had a root 2. Square root of a negative, thank you, is, let's say, impossible. We can use imaginary numbers, but you don't learn that in high school. If you continue in math, you will learn imaginary numbers. So we cannot do this, not possible. We could write also no solution. We know when we're talking quadratics, when we say no solution, we know that quadratics, they can have 2 possible solutions, right? When it crosses the x-axis twice. There can be 1 possible solution when it touches the x-axis, and there's no solution when the quadratic does not cross the x-axis. So when we say no solution, when we get a negative under the root sign, what we're saying, it must be something like this, right? Or maybe it's opening down. But the fact is that when there's no solution, it does not cross the x-axis. Okay? Let's move on to the next one. Square root of 27, of course, there's no perfect or whole number that multiplies to 27. We know, though, that 27 times, 3, or 3 times 9 is 27, and 9 is certainly a perfect square. So here, too, the square root of 9 is 3, and we're left with a 3 underneath the root sign. Square root of 5, only 1 and 5 multiply to that, so that would be our answer, and we would leave it like that. We could type that in your calculator and get a long decimal, but of course we want exact answers, not rounded off answers, so your answer would be left as the square root of 5. Square root of 112, you would have to look using your calculator or your mind to see what perfect squares go into 112. Perfect squares are 1, 4, 9, 16, 25, 36, 49, etc. going up. 16, I believe, goes into 112. 16 times 7 is 112. So the square root of 16 is 4, and then we cannot take a square root of 7. It stays under the root sign. And our answer would be left as 4 times the square root of 7. Not on your calculator with a rounded off decimal, but simply 4 root 7 would be an exact answer. If in your textbook, when you're doing questions like these, you are asked to round your answer off, then you would type that in your calculator. If you're asked for an exact answer, you will leave it looking like this. Let's do this one last example together. Identify your A, B's, and C's, please, and stick it into the quadratic formula. All right, so you should have been able to get it this far. We plugged in the 5, the negative 10, and the 3. And I manipulated this equation down to this bottom step. Now, here's the spot where we can reduce the radical sign. So we've got 40 is equal to 4 times 10, which 4 is a perfect square. So we can write that as, now if you don't want to write this step in your books, that's totally fine. If you can see it, I'm going to write it down just to show my work. So the square root of 4 is 2. Root 10 does not have a perfect root, so we write it like that. And then we've got 2 answers here. And did it say exact value or rounded off? I forgot to read. It says an exact value. So we're going to leave the square root sign in our answer. So we're going to have, actually first let's reduce it, because I can see the coefficients here when I'm talking about coefficients, that constant, that coefficient, and that denominator. They can each be reduced by 2, or dividing by 2. Square root of 10, it's like its own identity. When there's a square root around something, it's not 10. The square root of 10 means what times itself gives us 10. It's like 3.1 or something. So we can't reduce inside a root sign. Just the numbers that have been highlighted can be reduced. And we can see here, if I divide them each by 2, I would get an answer of x equals 5 plus or minus 2 divided by 2 is 1, so we don't need to write it. And 10 divided by 2 would be 5. Okay, and now we've got our 2 possible answers. We could write that out twice with the plus and then the subtract a second time. It would be the same thing as this. We're not finding those 2 answers. We want an exact answer, so that is our solution set, those 2 possible answers. If you wanted to be able to picture this quadratic, A was positive, it's concave up, you could type this into your calculator. 5 plus, it's like 3.1, so it would be 8.1 divided by 5. It would be 1 point something here. And then maybe the other answer would be 5 minus 3.1 is 2. 2/5 would be about here. It's a parabola, kind of a sketch like that. Okay, so we've had experience now with square roots. We've had experience with finding an exact answer, and we're going to leave it at that. If you wanted to do this assignment, you could go ahead and watch the other video in Google Classroom and just fast forward till the very end. It involves simply multiplying, foiling this out, finding your A, B's, and C's, and then plugging it into the quadratic formula. All right, good luck. We'll talk about this assignment in class and how much you should do.